Good afternoon. My name is Vũ Trần Ngọc Cẩn. Under the supervision of Professor Alexandra Cravo from the University of Angap, I have conducted the thesis on the impact of urban wastewater effluents upon the water quality of Ria Formosa, the case study of Faro-Olhão and Olhão-Poente wastewater treatment plants. The wastewater footprint discharge in the receiving water can cause the nutrient enrichment. Excessive nutrient load can lead to eutrophication, which induces harmful algae bloom. The algae can release the toxin, and their decay can cause the depletion of oxygen, which will affect the growth of bivalves. Moreover, the wastewater can also cause the microbial pollution. Enteric bacteria can be accumulated in bivalve tissues due to their immobilization as well as their filter feeding habit. Consumption of contaminated bivalves can lead to the risk in terms of public health, food quality, and food security. Formosa is a typical mesotidal lagoon in the south of Portugal. It's a Ramsar site which contributes 90% of national bivalve production for Portugal. With the semi-diurnal tides and fortnightly tidal cycle, the ecosystem here is very dynamic and it has a high biological production. Even though it's a shallow lagoon, but it is the hotspot for tourism, fishery, and aquaculture. The high tidal water renewal, this lagoon have still make the inner areas classified as sensitive to eutrophication. Previously, this lagoon received the wastewater from Faro-Olhão Center and Olhão-Poente. However, these two was decommissioned in October 2018. Now, the new wastewater treatment plant has already built called Faro-Olhão with a capacity of 14,000 cubic meters per day, which is equivalent to 100,000 inhabitants. This plant used the neap technique, which is an advanced technique not only in decrease the construction area, the retention time, but at the same time increase the efficiency because of the aerobic and granular sludge. Because of the importance of Ria Formosa, three aims of the study were identified. Firstly, the spatial impact of the discharge along the gradient dispersal encompassing the location of the clam beds. Secondly is the tidal influence between low tide and high tide, spring tide and neap tide. And last but not least, the temporal evolution of the after the implementation of Faro-Olhão and the decommission of Olhão-Poente. Regarding the sampling site, firstly, Faro-Olhão FO, there were two transect lines were identified in this area in the west and in the east of the discharge point. Meanwhile, in OP, only one transect in the south of the discharge point were identified. Each station is at least 250 meters apart from each other, and the station near the clam bed is highlighted with a star symbol. Surface water were collected in both low tide and high tide, and they are collected in the summer for both neap tide and spring tide, while in autumn and winter conditions, only the neap tide were considered. In the field, all the in situ parameters were measured by the multi-probe, and all the water sample were taken to the lab for suspended solid using the gravimetric method, the analysis of nutrient using Grashof method, and the chlorophyll A using Lorenzen and Jeffrey method. Concentration of E.coli were measured by the most probable number. After all the measurement, the data set is tested by the Shapiro wheel test for the distribution, if it's normal or non-normal. Depends on the distribution, specific statistical tests were applied for specific aim. For example, for the spatial effect, one-way ANOVA and Kruskal-Wallis tests were applied, while for tidal impact, Petty test and Wilcoxon-Sarang test, as well as Spearman rank correlation were applied. For the temporal evolution, I chose to use the TRIX index, which is TRIX, to evaluate the water quality, because this index not only used one parameter, but four main parameters, including chlorophyll A, dissolved oxygen, total nitrogen, and the phosphate in the water. The water quality is classified from high to poor in a scale from 0 to 10. The first result regarding the salinity in FO, as you can see, The positive value in the x-axis represent for the transect line in the east, while the negative value represent for the west. And for the salinity, the drop of salinity can go down to less than half the normal value. And as you can see, there's a large variation in the summertime. Next one is the autumn and winter time. The drop of salinity is not as high as in the summer. The lower salinity corresponded to high input of wastewater, and the tidal effect is the main driving mechanism that creates the gradient effect that extends until 500 meters around the discharge point. The higher strata of tourism in the summer is a major reason, a major cause for the drop of salinity and the higher load of wastewater. On the other hand, in OP, because there's no input of wastewater in this area, so the values in this in OP is more stable. Only minor variation were observed, and no spatial gradient effect, no temporal pattern were identified in this area. That's why in the following result, the data of FO is more focused. In the data of chlorophyll, as you can see, the peak mostly attained at the nearest station to the discharge point in springtime and in low tide. This because of the in the summer, the higher intensity and higher time of sunlight induce the bioactivity of phytoplankton, which result in the peak of chlorophyll A. Chlorophyll A affect dramatically into the pH and DO value. As you can see, the fluctuation in the summer for both pH and DO is very high in the summer, while in autumn and winter condition, because the less sunlight, so there is smaller fluctuation. And the strong dependency of chlorophyll in the nutrients suggests that the nutrient play an important role in the thriving of phytoplankton. Regarding the nutrient, ammonium is the most abundant form of total inorganic nitrogen. The ratio between nitrogen and phosphorus is really low in FO, is below 16, which is the red pill ratio, suggests that in this area, nitrogen is the limiting element. Nitrate is the second abundant form, which is proportional with nitrate, but at a larger scale. The high input of phosphate from the wastewater treatment is also a reason contribute in the decrease of the NP ratio. All of the nutrients share the identical distribution pattern. However, silicate is more or less has a dissimilar distribution pattern. The negative correlation between nutrient and salinity suggests that there's a gradient effect along the transect line. The values of nutrient decrease with the increase of salinity. A strong correlation with each other between all the nutrients suggests that they come from the same source, which is the wastewater treatment in this case. In the E.coli, concentration, the concentration of E.coli in the summer is quite low, and globally it is below the threshold imposed by the Environmental Agency of Portugal. However, there are two peaks of chlorophyll concentration in August and September at the edge of the transect line, which suggests that the source of this of the high concentration, it comes from the external source, not the wastewater treatment plant. The temperature in the summer play an important role in limiting the bacterial metabolism activity. The solar radiation, in accordance with the UV lamps, which is equipped in the wastewater treatment plant from May 2019, decreased the concentration of E.coli in the water. That's why in the autumn and winter condition, when temperature go down, decrease, the higher concentration of E.coli is observed, especially in February. The concentration, the peak, is 40 times greater than the threshold. Also because of this month, there was a large rainfall volume in accordance with the runoff. In summary, the driving mechanism forcing the water quality has the big role of the exchange range of tidal height. The values obtained in low tide, in both neap tide and spring tide, were higher than in high tide, but it's in different scale. The variation along the transect, as well as the difference between tidal region, is the higher in spring tide compared to neap tide. Most of the peak of own parameters, most of 50 meters from the discharging point, with a disproportional with salinity. The spatial gradient effect can be observed until 750 meters to 1,250 meters, depends on the parameters. The peaks in the spring tide is much higher than the reference station compared to the peaks in the neap tide. And the worst quality were observed in the eastern transect, because of the circulation pattern that come eastward. Regarding the quality improvement of FO and OP, as you can see here, the TRIX were calculated and classified as high, poor, moderate, and good. Because of the upgrade of the wastewater treatment plant from the activated sludge to aerobic granular sludge, UV lamp also equipped in accordance with solar radiation increase the treatment efficiency and at the same time decrease the bacterial concentration. As you can see, the worst water quality is observed in low tide of neap tide because of smaller volume of renewal water as well as the high retention time. The water station near the shellfish bed will highlight with the red, rectangle. Will always classify as the good to high quality, which is a good sign for the shellfish water in here. In the inner area around the discharge point is more sensitive to eutrophication, while in the further station near the reference point, it is less sensitive. In comparison with other lagoons in the world, for example, the Remola Lagoon in Spain, Dere Lagoon in USA, and Conceição Lagoon in Brazil, you can see they are on restricted circulation, and receive a large amount of wastewater from the treatment plant, but they have lower water quality and greater fecal contamination compared to Ria Formosa. Especially Conceição Lagoon is a micro-tidal lagoon, not a mesotidal lagoon like Ria Formosa, but it has the very good biogeochemical process and physical process. So the water quality in the upper part is a good quality, while the bottom facing the threat of becoming a dead zone. In conclusion, in Apple, the water quality is classified from poor to moderate until 1,250 meters, and it was in the eastern side. Some impact of fecal contamination were identified from external source, and no wastewater footprint were observed. In OP, and the quality here is from high to good. Strong tidal effect is the influence the dilution ability and result in the maximal impact during low tide. The most extreme value were recorded in spring tide, but the worst water quality is observed in neap tide. Regarding the temporal evolution, in Apple, no considerable improvement observed in the first 6 months, while OP improved rapidly at the first 2 months. Summer is the favorable condition for the development of phytoplankton. Thank you for your attention. I would like to say thanks to my professor, Alexandra Cravo, Katia, and Andre for helping me through all the thesis. I would like to thank my friend and family, and also acknowledge the COMPRA project for financially support my thesis.